And our other drama people that are out too. So we've got x squared minus 2x over 4x squared minus 12x. Where do we start? Somebody tell me what to do. You want to find asymptotes first? Okay, that's a good place to start because that's where we're going to start with graphing. So Ender said he'd factor. That's always a good thing to do too. We can do that. Those two things are kind of related to each other, aren't they? So, but the horizontal asymptote we can see without factoring. What's the horizontal asymptote? Y equals negative 1 over 4. This assignment was a little heavy on oblique asymptotes. I didn't intend to give that many. I just didn't pay that close attention to how many of those I gave you. But horizontal asymptote is y equals negative 1/4. That's because the degree of the numerator and denominator are the same. The leading coefficients 1 over negative 4 is negative 1/4. So, factoring is a good place to do. Good thing to do next because we have to find the vertical asymptotes. So that's x times x minus 2 over negative 4x times x plus 3. All right, so do we have a vertical asymptote? What is the vertical asymptote? X equals negative 3. Why is x equals negative 3 a vertical asymptote? Because it makes only the denominator equal to 0. What's going on with the two x factors there in the numerator and denominator? What's that going to give us? Those are going to cancel. That's why it's called a removable discontinuity, because we can actually cancel out the discontinuity. We can make it go away, but it's kind of still there in our original problem, and that is a hole. So we have a hole at x equals 0. Now we're going to actually find out the location of the hole by taking this thing in its simplified version. So you can cancel the x's, and what do we have left? We have x minus 2 over negative 4 times x plus 3. And I can evaluate that when x equals 0. What do I get? Negative 2 over negative 12, which is positive 1/6. So I have a hole at 0, 1/6. That would have been the y-intercept, but because there's a hole there, technically this graph has no y-intercepts. It goes right up to the y-axis, but there's a hole on the y-axis. That's where the hole is, at x equals 0. All right, what about the x-intercept? X-intercepts come from values that only make the numerator 0. So 2 is my x-intercept. What's the domain? All real numbers except for 0 and negative 3. Okay. Remember, there's two types of discontinuities with rational functions: holes and vertical asymptotes. So if you have a hole or a vertical asymptote, those two values give you your domain throwaways. Those are the points of discontinuity. Points of discontinuity are attached to domain. And we were being more specific. I know the direction said find all points of discontinuity. Holes, vertical asymptotes, those are the two types. Identify which is which. Okay? A hole is a discontinuity that we can actually remove and get a simplified version of the function that we can work with. A vertical asymptote we can do nothing about. We can't get rid of the x plus 3, so that factor is really messed up. That's all the pieces of information we're going to find for this one. So our horizontal asymptote is y equals negative 1/4. That's just a horizontal line just below the x-axis here. Y equals negative 1/4. X equals negative 3 is our vertical asymptote. Okay. And then what other points do we have? We have our hole at 0 and 1/6. There's a hole in the graph. Dear Liza, dear Liza. There's a hole in the graph. How's that song go? There's a hole in the bucket, dear Liza, dear Liza. There's a hole in the bucket. What's dear Liza, a hole? Yeah. So there's a hole in the graph, dear students, dear students. There's a hole in the graph, dear students. A hole.
I've never heard that.
Y'all have never heard that song?
I've heard it.
It's an old, parents used to sing to their kids. Now they just give them, here, play with this iPad. Y'all are so abused. All right. There's an X intercept at 2 right here. I have no idea where that song came from, but several of us knew it, right? Do what?
DC choir class, we had to learn how to play it on those plastic recorders.
Oh, great. All right, so that kind of tells us real clearly what the graph is going to do on this side. It is connected to that hole, and then down here it's going to hug that asymptote forever. Okay? So the question remains, what does it do on the other side of the vertical asymptotes? We've got to figure out what's going on over there. Now, what does your experience kind of tell you it's going to do? Yeah, it's most likely going to be down here, right? How can we confirm that? Plug in a number immediately to the left of that asymptote. I would use -4. If we plug -4 into, we could plug into this simplified version. It's a little bit easier, right? If we evaluate that at x equals -4, we get -6 over -4 times -1.
And why did you choose -4 again?
Because it's on the left side of the asymptote.
Okay, just anything?
Yeah, that'll tell me if it's up top or down below.
Okay.
That's all I need to know. I know the shape of it, so I just need to know the location of it. And this looks like it's going to be a negative number, which tells us it's going to be down below. That's -6 over 4, which is what, 1 and 1.5, -1.5, -3/2. So at -4, the graph is at -1.5, so that is right here. And it's going to go down from there. Hug that asymptote and curve around and hug this asymptote. That's what we're looking like. Okay? Now, there is a repetitious process here that we're going through. The thing that you have to know is all the little rules to finding this. What are the rules to finding the horizontal asymptotes? What are the rules to finding the vertical asymptotes? If we can find those rules, then we're going to do better at, if we know the rules, we're going to do better at sketching the graphs of these rational functions. Okay? All right, next one. Number 2. Okay, now what do you notice right out of the blocks? If you know your asymptote rules, what do you notice right out of the blocks for this one? It has an oblique asymptote because the degree of the numerator is larger than the degree of the denominator.
Is there ever one with the denominator bigger?
We need to do one like that. If the denominator is bigger, y equals 0, the x-axis is a horizontal asymptote. Okay, and we didn't have one like that in this. What I'm going to do in just a second after we work this one, we'll change one of the problems to one of those cases, and then we'll kind of see, because we really need to deal with that case. So we've got an oblique asymptote. Oblique asymptote at wherever -4 or whatever, -4x squared plus 8x divided into x cubed 0x squared minus 9x. I don't need the zeros because we're just not going to get that far. Really, we just need the first 2 steps in this process when it's a linear quotient. So x cubed divided by -4x squared gives us -1/4 x, right? Multiply that times negative 4x squared plus 8x, and we get x cubed minus 2x squared. And then we change the signs, and that gives us 2x squared. You can bring down a negative 9x, but we don't really even need it. 2x squared divided by negative 4x squared is negative 1/2. So y equals 1/4 x minus 1/2 is my oblique asymptote. All right? Y'all okay with that process? So there's another skill we add to the list. Why did we learn that skill of long division, that weird skill of long division? For this. This is one reason. Because it gives us what the oblique asymptote is, right? So the more algebra you learn, the more you kind of see the significance of these skills that we just don't really understand. Why are we learning how to do this? Well, we're learning how to do it because it has a use. It's actually tied to a much higher use in calculus, where you'll be finding the limits, right? So it's kind of, we're messing around with limits here. Infinite limits are the asymptotes. So the top is x times x squared minus 9, which factors as x times x plus 3x minus 3. The bottom is negative 4x times x plus 2. There's a hole in the function. We got a hole in the function here. Okay. X's cancel, right? So I've got a hole at x equals 0. Let's see, we've got our oblique asymptote. I'm just getting all of our information compiled here. We have a hole at x equals 0. Let's find the location of the hole. How did we find the location of the hole? Take that function and remove the discontinuity. We can cancel out the x's, remove that discontinuity point, and that leaves us with x plus 3 times x minus 3 over x plus 2 and a negative 4 hanging out there. Don't forget that. We need to evaluate that at x equals 0, and we will get negative 9 over negative 8. 1 1/8. 9/8, right? So the hole is actually where the x-intercept would be, 0 and 9 over 8, 1.125. All right? Do we have a vertical asymptote? X equals negative 2 is the root of x plus 2. Right? So you got x plus 2. What's the root of that? It's negative 2. All right. So we're ready at this point to say what the domain would be. We don't necessarily need to say that at this point. But the domain is all real numbers except for, in the case of rational functions, the values where we have holes or vertical asymptotes. So the domain in this instance we've got is... Holy smokes. Okay, we got a mistake all the way back here. Can't believe y'all let me do that. X minus 2. So we got some stuff to correct, don't we? X equals positive 2. Sorry, YouTubers. So this is minus 2, right? This is minus 2 right here, which makes this positive 8. And changes this to negative 9 over 8. Is that better? I think we fixed everything. So the domain is all real numbers except for x equals 0 and x equals positive 2. Heather, you were too kind to me.
I thought it was like my work, so I was like...
No, I make mistakes. I make just as many mistakes as y'all do. I'm only human after all. Hey, it's a music day. I'm only human after all. Isn't that a song? Right? Is that right, Walker? You want to sing it for us?
No, I don't know the words. Just kidding.
I don't know the words either. Just those.
I gotta get.
I'm only human after all. That's 5 words. That's all that is. Is a who? Is a who?
I think there's 2 songs. I just know one by Christina Perry called Human. That's all I know.
Christina Perry? I don't know who
I
that
gotta
is.
say my voice was
Is she Katie's sister?
It's
All right. Domain, vertical asymptote, horizontal asymptote. What about y-intercept? We don't have a y-intercept, right? There's actually a hole where the y-intercept should be. We found it. It's x equals 0. Y would be negative 9/8 if x could be 0, but x can't be 0. So there's a hole in the function. X-intercepts. X-intercepts. 0 is not an x-intercept. Plus or minus 3. 3, 0, and negative 3, 0. That's what you said, right? I think we're ready to graph. Let's start with that oblique asymptote. Now, when you have an oblique asymptote, it's very important to graph it carefully, right? Because we got to know which side of that asymptote our function is on. And so use a lot of points there. Y-intercept is negative 1/2. And the graph, the slope is negative 1/4. Right, so that's up 1 and left 4. Up 1, left 4. Or down 1 and right 4. So that's our asymptote line there. Okay. Vertical asymptote at x equals positive 2. So positive 2, we have a vertical asymptote line. And what else do we know here? The y-intercept would have been 0 and negative 9/8. There's a hole there. All right, there's a hole there. That's nice. It tells us where the graph is in that region. Okay. And then x-intercepts at 3 and negative 3. So I got an x-intercept right there and right there. That's really, really desperately close to that asymptote line, isn't it? So this is going to go like this. Hug that asymptote there and gonna dive down there and hug that one, and then on the right side does the same thing. Make sure that you are careful to not show a graph crossing a vertical asymptote. It cannot. It's okay. It's actually going to be colliding, and graphs can actually go back and forth on either side of a horizontal or a oblique asymptote, but it's a big no-no to cross a vertical asymptote. That's a broken part of the function. It doesn't exist there. Okay? What do you think? All right, let's... can I clear this? Is everybody good with this? You guys seem to be doing okay. You doing better?
Yes.
All right. Let's go to... let me see if I can do this from here. Let me escape from this view. And let's go to the next problem. I want to actually change it. I want to change it to something that has a... Yeah, let's do this one. All right, so let me go back to my presentation view here. This one's a little different, right? What's different about this one? The numerator is a constant, right? The denominator can be factored as x minus 3 times x plus 1, I believe. Now this is the first one that we've seen like this. What is my horizontal asymptote?
0.
Y equals 0, right? The horizontal asymptote is y equals 0, which actually is the x-axis, right? What's the vertical asymptotes? X equals 3, x equals negative 1. Do we have any x-intercepts? Are there any x values that make the numerator equal to 0? The numerator can only ever be 1. And if the numerator can't be 0, then the fraction can't have a value of 0. So there are no x-intercepts. All right, what about y-intercepts? X is 0. What is y? Negative 1/3. All right. What else? Do what? Domain. All real numbers except for 3 and negative 1. That's correct. Now we're ready to sketch, I think. We're going to have to find some points on this one. Horizontal asymptote is the x-axis, which is y equals 0. And I got two vertical asymptotes at x equals 3. And x equals negative 1. I have a y-intercept of 0 and negative 1/3. Got a y-intercept right there. That's all the points we have to work with, right? So we got to find some points to help us out on this one. Because what are the options for my graph at the bottom?
Going down because it can't finish that.
Very good. It has to open in both directions because it can't cross the x-axis. Why can't it cross the x-axis? Because the function has no x-intercepts. Beautiful. So we don't really need any other information in the bottom. This thing has to go down like that, and it has to curve around and go down like that. Now you could plot some more points if you wanted to find out what it looks like, and I apologize for that being so crooked and shaky, but it happens. All right, now we've got to find out on the right-hand side and on the left-hand side where the function is. Yes, sir.
So we don't have to it's not going to be in all 6 squares.
It can't be in all 6 squares.
So it can only be in 3 of them.
It can only be in 3 of them. Right? You can't have a piece of graph up here and a piece of graph down here. Why not? Because then it's no longer a function, right? It fails the vertical line test. So, yeah, there's a lot of things we're working with. These are functions. They're broken functions, but they're functions. Okay? So we got to pick a point. Let's say take x equals 4 and plug it into our graph. If we take f of 4 is 1 over 4 minus 3 times 4 plus 1. That's 1/5, right? No, 4 minus 3 is 1. 4 plus 1 is 5. Yeah, it's 1/5. So where does that tell us? At 4, it's 1/5, so it's up here. How do we know it's not going to cross the x-axis? Because we don't have any x-intercepts. So it's curved like that. Yes, ma'am?
Okay, so about that, I feel like if I was looking at that, I wouldn't go across the x-axis just because the line is there. Is there ever a time when it goes through the line?
It can in the middle. It can if x is small. Remember what the horizontal asymptote does. The horizontal asymptote tells us what the function looks like when x is large. So the bigger x gets, the closer it gets to the asymptote. For small x values, it can cross. I think we did one yesterday that actually crossed in the middle, right? It crossed it and went up. Okay. You can. It's okay to cross an asymptote. As a matter of fact, when we get to trig, I'll show you some functions. Trig functions can oscillate and cross the x-axis an infinite number of times, even though the x-axis is the asymptote. We're limiting it or squashing the curve down.
Say if like the x-intercept had like 2 or something, then
If there was an x-intercept of 2,
I'm just like saying that.
then it would have to go like that.
Okay, so it'll be the problem, like we'll know.
Yes. You may have to do some testing, but that's the whole deal, right? Use your asymptotes, use your intercepts, and then find points from there that you need. So now we need a point that's on the left side of the x-axis. Okay, excuse me, the left side of that asymptote at -1. So let's evaluate f of -2. My guess is it's going to be up top. That's my guess, but I could be wrong. I've already been wrong a couple times today. F of -2 is -5 times -1. Hey, that's the same value. It's 1/5. So it's up there too. So we got some real symmetry going on. If x is -2, we're at 1/5, and that's what the graph is going to look like. It's going to jump up there, take a sharp turn, and hug this asymptote. It's not going to cross the x-axis, because if it did, we would have a point where y equals 0, and this can't be equal to 0. No x-intercepts. Okay, are you better?
I think so.
Yeah?
And this is on YouTube, right?
It will be. And I've got a couple of snippets from yesterday's class that I haven't put up there also. So tomorrow's our last quiz. Friday and Monday, exam review and exam on Tuesday.
Do you drop a quiz?
I am going to drop a quiz, yes. It actually may already be figured into your grade.
Oh, okay, never mind.
All right, any questions? All right, finish that sheet for homework. There's 2 more questions on the back.